11 SAE Hybrid and Electric Vehicle Symposium in Anaheim, California, with Bob Larson. Bob is Director Emeritus of Argonne National Labs Center for Transportation Research, and a long-time veteran commentator and expert in the area of research and development. Bob, welcome to the Hybrid Symposium.
Thanks, Lindsay. It's always a pleasure to be here.
Oh, very good. Thank you so much. With your experience in working with Argonne and the National Labs, what role do you see the National Labs playing vis-a-vis the auto industry and the OEMs as we move forward?
Well, as you know, the National Labs are kind of a unique American creation. We exist in the space between government and industry and academia. We really are kind of like a wholly owned subsidiary of the Department of Energy, although we're not federal employees. But in any event, our mission is to be working on the fundamental scientific and technical understandings of the kind of core technologies that will be important in the next decade or so. And of course, I have colleagues who are physicists and so forth are probing the fundamental natures of the matter and all that kind of stuff. But we are on the applied side. We see our vision as trying to give our country the technological base of knowledge that will keep us competitive in the future and really push on what our key vulnerabilities as a nation, and that, of course, is petroleum dependency and related things. So we're all about energy, we're all about efficiency, and we're all about moving that technical bar forward. However, of course, we are not in the business of making anything except discoveries and so forth. So we need to transfer this technology to industry, and quite often we do partner at various levels with both vehicle manufacturers, but also component suppliers. And we realize that, we can have the smartest scientists and the best knowledge and stuff, but if it doesn't get out and actually lead to products that can benefit the country, it's kind of all for naught. So anyway, we've had this history of working in these areas, trying to push the boundaries and understand what the limits are for vehicle efficiency and, things like engines and fuels and fuel cells. Battery certainly is a very core Argonne technology, but all this is really driven by our national energy policy and our vision for where we have to be. So we're trying to put the country in the best place possible in this very competitive era, and of course really reduce our vulnerability with oil imports. I mean, that's kind of our key message.
Mm-hmm. Yeah. Are you going to be working closer with OEMs as time goes on? Are you, meaning Argonne and the other national labs, do you reckon?
Lindsay, that's a really important element of what we do, and you have to understand that the decisions we make and how the Department of Energy decides to allocate admittedly scarce resources, and these are taxpayer dollars after all, this is public money. I mean, this is not made in a vacuum. We have constant dialogue with our industrial partners, and quite often they work hand in hand with us to produce these big vision plans. Where are we going in the next 10 years in this technology? What are the real barriers? How do we approach this? And often that leads to specific working partnerships in areas. So I expect this is a trend that certainly will continue, and it will likely grow. And here's why. I mean, we all know that we've come through Carmageddon, or whatever you want to call it, the last few years. We've had our two of our major automotive companies go through painful bankruptcies. Ford is doing much better, but it has it's got a pretty big debt load too. I mean, and we see the rise of competitors all around the world, not to mention the Chinese coming. So I mean, so the point is, we've learned the power of collaboration. We have to work together, and by doing that, we can really leverage each other's strengths. I think the auto guys, quite honestly, don't have the resources as they used to be devote to kind of R&D that we do, because we are looking out, a decade or more in the future. Certainly, though, we need their direction, and there are some obviously very bright and experienced people in that industry. So we have got to work together to do that. And I think, in the past, we've helped them produce some very interesting vehicles way back to the PNGV days when there were the so-called 80 mile per gallon vehicles, and now we see this plug-in hybrid and moving towards more vehicle electrification, advanced hybrid systems, and that's an area I've been personally working in now for nearly 20 years.
Right.
I mean, so it's really cool to see all this stuff happening, and I think one of the reasons we've been so successful, both in our research portfolio and as an industry, is the fact that we have learned to collaborate. And it's, incidentally, I think this is something that we do probably better than most anywhere else. It's part of the American way of doing stuff. So anyway, I do think it's important, and I predict it will be even more important going forward.
Bob, do you think in the industry in general there'll be less pure development for development's sake, innovation, putting it on the shelf, kind of waiting, and more innovating and getting it into production?
Well, the interesting thing about scientific discoveries is that a lot of them aren't planned. You're looking for something else and you discover, hey, look at that, something weird happened. I don't understand that, why it happened. So I mean, there's no hard and fast rules, but in general, I think that is the case. 20 years ago, it was much more likely that there would be a fair amount of research funding in the autos themselves that would be devoted to some of these things. Now, I think the people's have a much, I don't want to say shorter time frame, but things are happening so fast. The industry is undergoing this massive transformation, which part of which we're witnessing here at the Hybrid Symposium. This is a big part of it. And you already know that the government is thinking very hard about what fuel economy legislations will look like post 2016. And we've heard some really big numbers floated. And I mean, that kind of changes the ball game. And sure, 2025, that's a little over 10 years from now, but we're basically talking about completely changing every vehicle and every kind of technology decision to reach some of those goals. So I mean,
within about 2.5 design cycles.
Yeah, and this is unprecedented rate of change. It is going to be. I mean, there's a lot of risk involved, a lot of money on the line, and this is extremely exciting, but it's a very challenging time. So. This is, again, driving back to what I'm saying about collaboration. No one can afford to go it alone. Nobody. We have to find ways to work together to overcome these problems. Otherwise, we won't be able to do it. And, history has shown that when these pretty impossible technical targets have been set, when we didn't really understand how we could possibly do those things at first, low emission standards, the diesel, emissions things just a few years ago. We've shown that with really focused efforts and good collaboration, it's possible to achieve really amazing things. And, there's no letting off the accelerator, right? I mean, it's going to be faster than ever. So,
spoken like a true engineer with a lot of technical background.
It's exciting.
Bob, you mentioned Argonne's expertise in battery development.
Yes.
And recently we saw Argonne's announcement that the labs would be releasing kind of patent rights to General Motors and I believe LG Chem in some cathode chemistries, which is very exciting. Do you see more of the national labs kind of taking their IP and putting it out into the marketplace like this?
Well, I do, very much so, and also because, again, our research has become more focused on, those areas where there's real barriers to the industry, and that there are critical kind of linchpins, I guess I'd call them, for these dramatic improvements we want to see. That I do think this is going to happen. I mean, Argonne is not alone in this, of course, but we've had a very long history in the battery development, and it's it's important for people to understand the technology we're licensing now actually was developed something like 8 or 9 years ago, and so I guess what I'm saying is that we've accumulated a really good fundamental understanding of the chemistry and the materials that and the processing things that are needed to drive these important improvements in energy storage. And so the technologies that have been developed, let's say the last 5 years, are just as exciting and maybe even more game-changing, but we have to understand that understanding something from a theoretical point of view is, of course, the foundation, but it's just the first step towards commercialization. So later on today, one of my colleagues is going to be talking about the development of lithium-air technology. This is something we're very excited about. We've made really impressive strides over the last 18 months or something like that. But you have to understand, we're, I don't know, 10 or 20 years away from real mass production of this technology. But the cool thing is we see the pathway. We understand the chemistry. We know there's maybe a 5 to 10 times improvement in energy
density
and power density, energy density, and also very good power. So, and we're thinking, this looks very, very promising, but way too early to put too much hope into this technology. Give us another good 5 years. Anyway, the point is, our government is investing in this technology, a whole family of technologies that take time to bear fruit.
Sure.
And so there is an amazing portfolio across the national lab system of these technologies that are kind of waiting to be commercialized and waiting for people to understand how these can be applied. And often there's a lot of kind of cross-cutting application of some of these things that it kind of takes a while for people to figure out, hey, you know what, maybe I could use that to solve this problem. And then just kind of parenthetically, I want to say the latest investments we're working on things like nanomaterials and really improving our ability to look at materials really at an atomic level and actually build custom materials to do specific tasks. And in part, this is what has driven the revolution in battery technology now. And I guess what I'm saying is it looks to us like there's huge potential to take the same approach and apply it to other kinds of problems. Okay, so
that's exciting.
Yeah, it is. It's really, really exciting, and I'm proud to be a small part of what's been going on. And I do want to congratulate my colleagues in the electrochemical side of our laboratory. Have done some amazing stuff with batteries. Okay, so anyway.
All right. Thanks so much for your time, Bob. Always good to talk to you, and look forward to the next time we get together.
Absolutely. Thank you very much.
Thank you, sir.
Pleasure.
Thanks.